Punjab is leading in the total fire counts. Farmers are evading the satellite monitoring. We have now satellite evidence from the multiple satellites. It creates a false image. It's not true. We'll face this very, very hazardous air pollution year over year.
Have farm fires in Punjab and Haryana really reduced? There's a huge difference between the official numbers and what other data shows. The government data shows that the number of fires in Punjab are a little over 5,000 till November 2025. That's a decline of some 90% in the last few years. But my guest today, a NASA scientist, has gone through a lot of data and found this number could be much higher, something like 10 to 11 times more. Joining me on this Earth Chakra podcast is Dr. Hiren Jethva. He is an aerosol remote sensing scientist at Morgan State University and at NASA Goddard Space Flight Center. Hiren, thanks so much for making time for this conversation and this explain on how this works and what you found. You've been saying this for the last couple of years. The first contentious question that we are trying to explain here and to understand here is on this gap. How have you counted the fires and how has the government agency counted the fires?
Yeah, Chetan, first of all, thanks for having me on this podcast. As I understand that all agencies in India and also abroad, including the researchers like myself, we are all using up to now the NASA and NOAA satellite monitoring data set, either from Moody's on Aqua platform or on SOMI NPP. But now most scientists and agencies are using the fire detection product at 375 meter resolution.
If I may just interrupt briefly, These are very technical terms. So these are all NASA assets? These are all NASA satellites and systems?
It's a NASA and NOAA together. SOMI NPP is a NOAA satellite, whereas Aqua is NASA's satellite. But they work in partnership, so I call it NASA and NOAA satellite. We all have been using this satellite data to track the post-monsoon crop residue burning season, particularly over northwest India, but in general over the entire Indian subcontinent. And up to 2021, we saw that the fires are increasing actually over Punjab and Haryana. But starting in 2022, we saw a sharp decline. And that decline happened gradually from 2022 to 2023, 24, and now this year, 2025. So the graph that you are showing here are for the Punjab and Haryana separately. So you can see that in 2021, there were like more than 70K fire counts, which is now reduced to about 5,000 in Punjab and is about 600 or 700 in Haryana. But when you look at the pollution, air pollution, or what we call aerosol loading over the entire Indo Gangetic Plain, over the last 4, 5, 6 years, actually the aerosol loading or the smoke air pollution has shown an uptick or an increasing trend, which doesn't add up. Like when you look at the fires and we look at this data from the NASA and NOAA satellite, they are showing a sharp decline, about 90% as this report says. But when you look at the aerosol pollution, it's actually increasing. So that's quite inconsistent between the fire.
So to simplify that would basically mean that the fires, if it's at this much, then that does not explain how come the actual amount of pollution is that much.
Yeah, so basically, during the post-monsoon season, and particularly in October and November, the major source of pollution over northwest India and in general over the entire Indo Gangetic Plain is the crop residue burning in Punjab, Haryana, in Uttar Pradesh, and all parts of, there are pockets in MP and also in southeastern India. There are pockets of very high density fires. But Punjab is overall leading in terms of the annual fire counts during post-monsoon as well as during March, April, during the springtime burning. But the fires that we see in the post-monsoon season is about 6 to 7 times higher than what we see in the springtime, March or April burning. And Punjab is leading, is a leading state in terms of the crop burning in entire India.
The official version, as we've seen, a year-on-year decline for the last 5, 6, 7 years. Why did you doubt the official count?
This is what I found last year, that when we looked at the more than 10, 12 years of data from SOMI NPP, VR sensor, the fires were declining, as you can see from 2020, from 2022 onwards, in 2023 and 2024, the fires were declining quite substantially. But the aerosol loading, what we call aerosol optical depth, which represents the entire column aerosol effect on the solar radiation, that is going up. And that actually made me a little bit uncomfortable, and trying to look at other data set other than the standard NASA and NOAA satellite. And that led me to look at the geostationary satellite data set from, for example, the South Korean satellite called Geocomp Set 2A, which has the Advanced Meteorological Imager. It's called AMI. Because that satellite looks at our Indian subcontinent at every 10 minutes. And in that satellite images, this is about last year analysis. So in the last year, we saw that there is a sharp increase in the late afternoon burning in those satellite images. You could clearly see the smoke cloud popping out, especially over Punjab after 3, 4, and 5 p.m. So that led me to think that the fire activities which were occurring before around 1 to 2 p.m., now it might have been shifted to the late afternoon, because satellite images were showing that there is a very sharp increase in the satellite signal, particularly at 4 micron channel, which is very sensitive to detect the fires. That's a primary data that we use to detect fires. And you could clearly see that there is a sudden increase in that signal at about 3 p.m. and that goes on up to 5 and 6 p.m. That led me to think that the fires that we are counting from the NASA and NOAA satellite, which is actually both of those satellites overpass northern Indian region around 1:30 p.m. plus or minus 5-10 minutes. So in those satellites, we were missing those fires which are occurring after 3 p.m. But now we can see that from the geostationary satellite, for example, in this case, the South Korean GK2A satellite with AMI sensor.
So the other thing is that the deeply contentious question is whether the farm fires are being lit later in the day to evade the satellite count that the government uses. How do we establish that? And we have this chart that you had shared. Using this, can you explain how do we establish that? How do we know this?
Okay, so I created this chart based on the last year's up to like 2024 data set. And as I said, that I started looking at first I doubted the NASA and NOAA satellite fire detection. I'm not saying that those detections were wrong, but we were missing a lot fires in those satellite data set. As you can see in this graph, there is this dotted box. That's where that's where we have this NASA and NOAA satellite overpass over the Indian region between 1:30 to 2 p.m. And when I looked at the geostationary satellite data and developed a preliminary algorithm to detect those fires over Punjab, and these are the basically hourly plot of the total fires detected for different representative days from 2019 to 2024. And I think all of the dates are in November. That's when we see the peak fire activities in Punjab and Haryana. So in this chart, it made me very clear that you see a very drastic increase in the fire signal between 4 and 5 p.m., especially during the last three years, like 2022, 2023, and 2024, which we didn't see in 2029, even up to 2021. Moving from the traditional and standard polar orbiting satellite fire detection monitoring to the geostationary, because now we are seeing more complete and total picture that NASA and NOAA satellites don't show us, because it's just a one-time snapshot of the fire situation over northern India. But now with geostationary satellite, we have actually every 10 minutes a snapshot of of what's going on there. But I'm just using here hourly data for the ease of the data analysis and computation. But in this chart, we see that the fire activities, the peak fire activities are now shifted to late afternoon.
Come back to the geostationary point in a minute, but I just want to underscore one thing, and I want to get your view on this, that you have been tracking this for a couple of years, but this has also been endorsed recently by ISRO, the government space agency, and they have said, and I'll quote over here, our analysis shows a gradual shift in peak fire activity from about 1:30 India time in 2020 to about 5 p.m. India time in 2024 to avoid detection by polar orbiting satellites, which is exactly what you're saying. And this indicates that the overall fire activity has not reduced. The link to the study is in the description below for any viewer who might want to study this a bit more. And this was also verified by ground reporting, I think by India Today about a year ago, and the matter went up to the Supreme Court, where they said that officials cannot permit farmers to burn stubble and instructed the Punjab government to issue immediate instructions to prevent such practices. With all this in mind, what should be the immediate change that the government introduces? I mean, both the Punjab government and the central government have reiterated that fires are down 90%. In light of this evidence, what should they be doing? Is this good enough evidence?
The 90% reduction report is quite misleading, because with the NOAA and NASA satellite fire detection products, which has been used by all agencies in India and as well as abroad. So if you are just using one time snapshot of those fires, we are not seeing the totality of the fire activities throughout the day. And since the fire activities has been shifted to late afternoon, those numbers are no more reliable. And we will have to now to switch to using the geostationary satellite data. For example, the South Korean satellite data. There is another European Union satellite called Meteosat 9, which is powered at 45-degree east longitude, which is seeing a large part of the Indian subcontinent. And there's another satellite, Chinese satellite, which is also sitting just around 100-degree east, so which is also covering a large part of the Indian subcontinent, as well as the adjacent Bay of Bengal and Arabian Sea. So no, we cannot rely on now our traditional and standard way of looking at this fire data from the polar orbiting satellite from NASA and NOAA. We have to switch to using the geostationary platform to look at the time evolution of this fire, and especially it's more important now because the fire activities have been shifted to late afternoon, and we are missing all of those fires in the NASA data.
India has these geostationary satellites of its own, or does it need to use these foreign ones that you have cited?
That's a good question. No, India also has INSAT series of satellite, and it carries the I think it's INSAT 3DR, which has the 4-micron channel, which is the primary observation that we use to detect the fire. So yes, we can also use the Indian geostationary satellite.
So now I want to do a bit more on the geostationary satellites and why this is better. Now we've got these images from a couple of these, plus there is also the Japanese one,
Right,
which shows the smog over North India. Using these, what is the advantage of this versus the polar orbiting ones?
So we are seeing here a snapshot of the entire disk of the Earth from European satellite Meteosat 9 and South Korean satellite GK2A. So the benefit of geostationary satellite is that we get a high temporal frequency snapshot of the region it's looking. So we get very detailed information of, like, for example, aerosol plumes for fires, even clouds, and so on. We can see high frequency changes in this entire Earth and atmospheric system. And in polar orbiting satellite, we have about one or twice, mostly one time a day, a snapshot of that region. So we just get the information about that particular time, but not before or after that.
So if we just imagine this or use an analogy of a cricket match, a cricket stadium, these satellites, these geostationary satellites could be like cameras, or in a room, it could be like CCTVs, which are permanently fixed on an area.
Yes,
But the
orbiting
pole orbiting satellites are just making rounds of
rounds.
the Earth.
Yeah.
Similarly with this. So with that in mind, there is a fundamental difference between this apart from where they're positioned. Also, the distance from the surface of the Earth, right? Geostationary satellites are much higher, I think, what, 35,000 feet
36,000,
or,
yeah.
sorry, 36,000 kilometers or something like that. Can they pick up the kind of detail that you want to identify fires at maybe a kilometer, a square kilometer, or even less than
Yeah,
that?
it
Is the resolution good enough?
yeah, it depends on the type of sensor that we have fitted to those geostationary satellite. For example, this South Korean satellite, its native resolution is about 2 kilometer. But when it looks at the Indian region, particularly Northwest India, that resolution degrades to about 4 kilometer. It's still okay to detect the fires, but for example, in the polar orbiting satellite, for example, SOMI NPP VIRS, it detects fire at 375-meter resolution. Of course, it has a very great resolution, but it's just a one-time snapshot of that region. So that there is some trade-off here. If you use this two particular satellite that we are seeing on the screen, the resolution is about 4 kilometer, but it gives us every 10 minutes or every 15 minutes snapshot of that region. So we can track those events like air pollution events, the fires and clouds and so on, at very high frequency.
Showing a few more images of the satellites and of from the geostationary satellites. The question is this, that a lot of satellites can't see through clouds. And when there's smoke, then you have a lot of smog. Given the smog, would the fire count still be accurate, or would there be some kind of an error?
Uh, Again, it goes back to the resolution. We may not get that kind of accuracy all the time here with this coarser resolution geostationary satellite sensors, but it is still sufficient to track the time dependent evolution of the fires from morning to late evening. What I learned from the geostationary satellite data that we can confidently track these fires with some good reasonable accuracy from morning to morning hours to the evening hours.
Just go back to this original image, this graphic that we began with. Given all that you have explained so far about the satellite technology and how you use it, could you talk us through how you came to these figures of about 57,000 fires for Punjab, whereas the government figure is 5,000, and about 24,000 for Haryana, whereas the government figure is about 700?
That's true. Okay, so I believe that the government figures are based on the SOMI NPP VS fire detection at 375 meters, and the SOMI NPP satellite overpasses the region around 1:30 p.m. And since the fire activities are shifted towards late afternoon and in the early evening hours, we are not seeing a totality of the fire activities, and that's why we are seeing very less number data every hour from like noon to 1 p.m. to so up to 5 and 6 p.m. We are getting more fires detected. The fire activity peaks around 5 p.m.
Your estimate of 57,000 is broadly accurate.
It's more
57,000 and
broadly accurate
24,000.
than the NASA estimates.
Got it.
Yeah. I'm not saying the NASA satellite is doing it wrong. No, there's some problem in the algorithm or data. No, it's just reporting what it's seeing at 1:30 p.m. So those are also data is also accurate, but that's not complete.
The other question is, or the other issue is about these farm fires, that they don't pollute just Delhi. It's a North India problem. But as your data also shows, this same smoke, the pollution from the fires in Punjab and Haryana and Western UP, they travel to other parts of the country. How does that happen? Tell us what we are seeing in this image and the next one that I'll just be showing.
So when you're talking about the what we call long range transport of the smoke from say Punjab, Haryana, and there are also fires in the UP also. So during this particularly November time period, the winds are mostly northwesterly. It flows from the northwest to the southeast. So those winds carry those smoke particles or pollution along the entire Indo Gangetic Plain, and then it goes southward over the northern part of the Bay of Bengal, and then it takes turn to the westward turn, and it flies along the eastern coast of India. And I have seen, based on the past year's data, that the smoke from northern India, after traveling through the Indo Gangetic Plain and north of Bay of Bengal, it actually reaches to the southern part of India up to Chennai. But you can see this in this image, that look at this whole area, the northern plain between the tall Himalayas, and in the southern part we have the Vindhyas mountain range. So this whole smoke pollution is trapped between those two topographies. You can see there's a lot of haze in the central India, and we do have the fires in the Madhya Pradesh during this season. Remember, this is the crop harvesting season everywhere in India, and farmers in many states, they resort to burning to clear the land very quickly and prepare this agricultural land for the next winter crop. So we do also see fires in the Madhya Pradesh, and in this particular image, what happened that the wind patterns were such that the smoke from the Madhya Pradesh, it actually descended southward over the parts of Gujarat and along the western coast of India, including this Mumbai here. And a few days ago, we saw a huge spike in the air pollution and degrading AQI over Mumbai, and that was because of this long range transport of the smoke from central India to over the western coast.
Really quite fascinating on how this crisis can actually affect not just a small part of India, but a huge part of India, right up to Peninsular India.
Right.
But why do only Punjab and Haryana get the blame for this pollution? It's predominantly, if you look at the headlines of the last couple of months of October and November, stubble burning tends to dominate the whole pollution discourse much more than the other sources of pollution. Now, you shared this image with me. What are we looking at? What is the takeaway from this?
Okay, so in this map, we are seeing the annual, total from January 1st to December 31st. We are looking at the annual fire counts all over India here. This is for the 2018 map, and in this map is that Punjab and Haryana, those two states are leading in the annual fire counts. Followed by, there are pockets in the Madhya Pradesh, in the Chhattisgarh, in the southeast parts of India, and also there are few pockets in UP and Bihar. But the striking feature of this countrywide map of fires is that the Punjab and Haryana are burning the most annually, and they go through these two crop growing season, one in the monsoon season, which is a rice growing season, and one in the winter, which is a wheat growing. So after the harvesting of the rice and the wheat crop, farmers resort to the burning the leftover, what we call crop residue or the stubble. And those two states are the northwestern states are leading in terms of these burning activities.
In this map, those are the yellow and red bits.
Those are the green, yellow, red. Yes, those are the higher fire counts on this color bar.
So why are these two states the worst? Because they are not the only states which actually burn, which actually grow badly. Many other states also do. So why do they dominate the fire landscape by so much?
Very good question. I think we need to go a little bit back in the history. This is again based on some literature survey. I'm not an agriculture expert, but the literature survey says that the Green Revolution, this goes back to the Green Revolution, which was introduced in mid-1960s. Under that, it's first of all, let me admit that it has been a huge success. The Green Revolution has been a boon to our country, which made us self-sufficient to feed more than 1 billion people now, and we have become also an exporter. So it has been a huge success, but there are some I would not say drawback, because it connects to the how we manage with this crop residue. So when this green revolution introduced with the introduction of the mechanized, harvesting, use of fertilizers and so on, rice was not a native crop to Punjab and Haryana. Remember, only that wheat and some other crops were the major agriculture products of those two states, and also that's true for the UP. But the rice was introduced in the northern belt under this green revolution, or what we call the two crop rotation system. And if you look at the past data, the rice production over Punjab was less than 1 million ton in 60s, but which, because of the use of the machines and mechanized harvesting and the fertilizer, crop production increased substantially from 1 million ton to now about 14 or 15 million ton in the present day. And with this huge amount of crop production, we are also left with a lot of crop leftover, or what you call residue. So, for example, there are estimates that if we have 1 million ton of rice production, we have about 2 million ton stubble left in terms of mass. So there's a huge amount of leftover, lying on this agricultural fields. And particularly, I'm talking about the rice crop, which is high in the silica content. And because of this high silica content, we cannot feed this to animals as a fodder. And right now, farmers don't see any value in this stubble, the leftover after the harvesting. And for farmers, it is easiest and cheapest and the quickest way to get rid of this stubble is to burn it, because they have a very short time window to go from rice to wheat. And this is the cheapest way for them to get rid of the stubble and prepare the land for the next crop, which is a winter time wheat crop. So that's why if you look at the historical satellite data, of the crop production, and also the satellite observation of what we call the greenness of the cover and the fires, they are all increasing from early 2000 to now. So all of these different measurements from the satellites, and also if you look at the crop production data from the agricultural department in India, they are all on the same page. And the crop production is increasing, hence stubble amount is also increasing. And because of the shorter time window to go from rice to wheat crop, and there are no alternatives yet available to every farm, this huge amount of stubble, I think farmers are resorting to burning, because that's a very quick and cheap way to clear the land.
Well, the government says that they have, I think, increased all the machines, and a lot of it is free, especially for the low income and small scale farmers. But clearly, the evidence seems to suggest there's a lot more burning going on. I just want to touch upon one more thing, that stubble burning is about 10% of the air pollution in Delhi and its neighborhood. And this is according to data from the IITM. You have described the dense pollution as a river of smog across the north. How much of this pollution is from stubble burning? And how much is it from compared to sources like vehicles and burning for cooking and warmth and waste disposal and industry?
So let's start with the contribution of the crop burning smoke to different parts of northern India, including New Delhi. Now, these models are based. This model, they are like short range forecast model, which can give us the forecast for next few days. And these models are fed by, or what we call assimilated by the fire products from the NASA and NOAA satellite. And we have discussed earlier that since we are not seeing the totality of the fire situation in the NASA and NOAA satellite, the models are not fed with the correct amount of fires. The models are fed with very fewer amount of fires starting from 2022 and even including this year. So there is not enough smoke already. There are not enough fires and smoke in the model, and that's why model is heavily underestimating the smoke content. For example, to Delhi and also downwind region. So remember this temporal shift in these peak fire activities have messed up not just the satellite, the long term satellite monitoring of the fire accounts, but it has also messed up the model calculations, the forecast models, because now those models, since all those models are relying on those NASA and NOAA satellite data, and we are not seeing enough fires there, the model simulations are also not reliable under this new fire regime. Models now need to use or assimilate the fire detection from the geostationary satellites. So I cannot make any further comment on how much, because I'm not a modeler, but I can clearly see that those models prediction and simulations of this percentage contribution of crop fire smoke to Delhi's pollution or any other pollution in other cities, those are highly underestimated. And I don't find those numbers are reliable now.
Hiren, I'm a bit curious to know one thing. You've done a lot of work. You have data, information, you've cross-checked it. There are other sources now lately. ISRO has also confirmed or tends to endorse what you've been seeing in the last few years. I'm just curious to know, has the Indian government or any Indian agency reached out to you for your information? Are you working with them to work out some kind of way of getting a more accurate picture of how much pollution there is, what is causing it, of the fire counts?
Okay, so far I think I haven't been approached by any Indian agencies about this geostationary satellite data. I'm sure researchers in ISRO, they might be working on the geostationary satellite data. For example, the Meteosat, the paper that you cited, that there is a research paper came out just recently, like just a few days ago, using the Meteosat, the European satellite data to look at the fire frequencies over Punjab in India. But that's a good start. And I had some conversation with some scientists in IITM Pune last year about using this new fire data set from the geostationary satellite data. But I think we haven't made any significant progress on this. But now it's a very high time that we collaborate on this very important issue and try to now use this geostationary satellite data in the assimilation process in the models, and let's see how models simulate the smoke in that region.
Absolutely, because I think ISRO definitely is doing fantastic work. IITM has a great track record. So we have all the equipment, we have the talent for sure to get a better, more correct picture. And I would imagine that the more we measure this accurately, the more action we can take to prevent this.
I agree.
So coming back to this issue of the fact that rather than improving, as the government data shows, it may actually be worsening. Why is this problem not getting solved, or it seems to be going from bad to worse, actually?
Very good question. I mean, the government numbers say that there is this 92% drop in the fire counts, but as I told you earlier, that it's not reliable. Actually, if you look at the geostationary satellite data that I shared with you, this year in 2025, we are seeing about 30% more fires this year compared to the last year in 2024. So fires have increased. I'm talking about Punjab mainly. Fires in Haryana, they remain more or less stable over the last few years, but Punjab is leading in the total fire counts. And I was a little bit disappointed to see those numbers, like 90% reduction, despite my every effort that I started last year to convince researchers, scientists, and also the agencies in India that look, now if you look at the geostationary satellite data, we are seeing more fires. This has been happening since 2022, but we realized last year only. But 1 year has passed, but after even putting so much of evidences from multiple satellites, and they're seeing this, there's a Korean satellite, there is a Chinese satellite, and there is a Meteosat, a European satellite. All of these 3 satellites sitting at different positions but seeing the same region and showing us the same picture. Okay, and there are ample and very convincing evidence that now the fires have been shifted to the late afternoon, and we are not accounting for those fires in our reporting. For example, this 90% reduction report, those numbers are not accounted that we are seeing in the late afternoon. So it was disappointing to see those numbers, because it creates a false false image in the media and to the general public that Punjab has reduced fires by 90%. It's not true. Punjab has actually increased fires have increased about 30% compared to last year. And actually it is even more than 50% than compared to 2019 or 2020. So I think those reports are, I think, false and misleading. And government needs to revisit those numbers and now start using the newer way of looking at this whole fire situation from geo platforms.
Quickly before I move on to my last couple of questions, what is this pollution made of? I mean, one would imagine it's carbon dioxide, of course, but anything else that one should know, especially from a health point of view?
Good question. So these are what we call smoke aerosols or smoke pollution, which has 2 components: the particulate matter, which are very tiny particles of very fine, what we call fine mode particles, and other component is the gaseous component, like carbon dioxide and also some ozone formation, nitrogen dioxide, formaldehyde. All of those are very hazardous to human health, but also the particulate matter. And since these are very fine, it can easily get through your respiratory system and directly to your lungs. So those particles are not filtered by our nose. But the large particle like dust, okay, they are filtered by our nose, but the fine particle that directly goes inside our respiratory system and that deposited to the inner linings of lungs. And this,
Given that,
yes, so this particle, the smoke particles are mainly composed of what we call carbonaceous stuff, like black carbon and a suite of a variety of organic carbon. So those are the 2 main components of the smoke particles, and there are some other could be some elements in the smoke particle, but mostly this black carbon and the what we call in general terms is called soot particles, and the other is organic, and all of them are very, very unhealthy basically when it is inhaled in our respiratory system.
So to recap your information that you have provided us, the farm fires in Punjab are not 90% down. The fire count is actually a lot more. Probably it's up 30%, you estimate, over last year. In fact, the entire number of fires has gone up to something like 57,000 in Punjab compared to the 5,000 figure, the official figure. And those lighting the fires are evading the satellite. In a nutshell, this seems to be the main headlines from what you're saying.
True. Farmers are evading the satellite monitoring, the polar orbiting satellites of NASA and NOAA, and somehow they have learned that how to evade and how to avoid the satellite monitoring around 1:30 to 2 p.m. And this has happened not just on a few pockets in Punjab or Haryana, mostly in Punjab. It has happened statewide. So this is what the satellite data tells us, that this whole shift has occurred everywhere in Punjab. So that was statewide coordinated act that farmers are now following, and it is unambiguous and undoubtedly that we have now satellite evidence from the multiple satellites, okay, to tell us that majority and most fires are now occurring at around 4 to 5 p.m. And there is no question about it. So if we deny that fact, and government is showing the lower numbers here, for example, next year, if they are showing even further lower numbers, that will not help us at all. We will see pollution level even higher than what we have already experienced this year in last 2 months. We're going to see again those level of pollution next year. So farmers can hide the fires, but they cannot hide smoke. They cannot hide the pollution. It is seen in the ground-based sensor, in the AQI, in the PM 2.5, and it is also seen from the satellites, the aerosol loading. So yes, I mean hiding this fires from the satellite monitoring is I would say very bad trick, and it's not going to solve any problem. We need to face this problem on our head. Yes, there is a fire. If we accept there is a problem, we can find solution. Hopefully, we can find some solution in the next few years. But if we say no, there are no fires, then there won't be any solution, and we will face this very, very hazardous air pollution year over year.
I think it's important to also remember the fact that it's not just you now who's saying it. Others have also begun to recognize this, and they have also been reporting it independently. You are really categorical about your reports, your data, and I do hope that the Punjab government, the central government, and various agencies, at least they start talking to scientists like you to at least have a conversation to get a more accurate picture and do exactly what you're saying, figure out how to tackle this problem, reduce the fires, and reduce pollution. Hiren, thanks very much for joining me on this podcast. I'm Chetan Bhattacharjee, a longtime journalist, now trying to simplify the science and solutions around climate change and air pollution. If you found this useful, please do share it with others who may find it interesting. And any questions or suggestions, please comment below.
Okay.
Thanks very much.
Thanks, Chetan, again for having me on this podcast, and thanks for giving an opportunity to share my results and share my opinion on this very important issue, the air quality issue in India.
Most welcome. Look forward to talking to you again.
Thank you.